Hello everyone, November 11th. Alright, let's do this. Minimum operation to make all elements equal to 1. Any number of times, select an index and then replace either of this or this with their GCD value. Return the minimum number of operations to make all elements equal to 1. GCD. Well, we can write a GCD ourselves, if you remember how. Maybe. So 2634. You can do the following operation. Select this and then replace either of this or this. Okay. So 3, 4, GCD1 now we have. So I replace this and choose this, replace, choose this, replace. So okay. Also not possible. So you're saying once we find a 1, and then everybody just can deal with 1, right? So you do one step, get 1, and then it's just the remaining. Yeah, because you have to make at least 1. So every number need to get changed. So at least it's the number, the length, right? At least it's the length. So basically the question is, what is the fastest way we can get to a 1? Now if we have a pair that is a co-prime, then you already have a 1. So we can go through everybody, try to see if we can get a 1. If we can get 1, then it's good, right? If we cannot get 1, then we basically will get their GCD, right? The GCD. And how do we tell if I don't know. So if a pair, the GCD is not 1, then we'll just replace. So we have, so basically this is the original, right? What we can do is this, we can get a B0, B1, B whatever. So this is their GCD, right? And we can check if any of this GCD is a co-prime, because we can put this one here, put this one here. Actually no, because if we do that, well, I mean, we can put this one here, right? And then this one can work. I can put it here, and then so yeah, we can like replace the number here, put the GCD here, all right? Put the GCD here. So basically the ideal is we want to see if the GCDs are co-prime. So in this case 2, 10, 6 and 14. So the GCD is 2, right? GCD is 2, right? The GCD is 2 and 14. So yeah, that's the first round. And then second round, GCD is 2, GCD is 2, and then GCD is 2. Oh, I think the last one shouldn't count. The last one shouldn't count, right? And then here, GCD is 2, GCD is 2, and then GCD is 2. So no matter how you do it, the GCD is going to be 2. So it's not possible. But if along the way we find a 1, right? Let's say this is a 1, right? So for whatever reason we found a 1. Then we know it'll take once, we'll take so each round will take 2, right? So this I need to take 1 to get this, and I'll take another one to get this. So I need to take 2, and so each roll is gonna be 2, except the last one. The last one will be only 1. So we just count how many rounds do we need to get to 1. So we count how many rounds, and then we have the total. And then we add the remainder, because they all need to GCD with this one. All right, let's give it a shot. Pairwise GCD until 1 shows up. Then we can like GCD the rest of the number with 1 to reach 1. We keep track of how many rounds needed to get 1 to show up. If 1 never shows up, it is not possible, right? Oh, I hope I got it right. So let's say A is the bigger one, B is the smaller one, okay? And then we'll do this, and then we'll basically replace them, right? So B is the smaller one. So if B is equal to 1, I think we just return A. Otherwise, return GCD B A mod B. So if A is small, B is big, then B is big, A is small. So eventually A is big, B is small. Okay, so that's that. So we just need to know how many rounds, right? Int rounds 0. And then we'll say and ed, right? Ed nums.size minus 1, right? So we say while ed is larger than 0, okay? For int I, 0i is smaller than ed I plus plus, because I cannot touch ed. We say nums I shall equal to GCD nums I plus 1. Right, if nums I is equal to 1, we'll return, right? Return nums.size minus 1 and minus yes, Yes, that's the total number of steps we need to take. They're just nums, size, and then plus rounds. If not, at the end, rounds plus plus. Actually, no, I think rounds times 2. Because each one needs 2 steps. And then if nothing, then we'll return -1. All right, let's give this a spin. Oh, that's a 0 then. Huh? How do we do GCD again? All right, 2, 6. Right, 2, 6, and 6 and 2. 6 and 2. 2, 0. Oh, my bad. I forgot to blah 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 rounds and ed need to minus minus. Got it from the loop. All right, this one looks solid. I'm gonna try it. Nope, it does not work. Let's see why it did not work. 6, 10, 15. All right, first round. This is gonna be 2. And this is going to be 5. And then this is gonna be 1. Right? So we have 1 round. So we need to get 2. Right, 2. And then plus 3. Okay, that's not right. Yeah, we have 1, 2, 3, 4, and 5. Okay, it's not right. Oh, because I can do this. Put 2 here, and then these will be 1. I don't know, like what so the previous is we will do here and then we'll do here, right? So this is like what we'll do here and then we'll do here. No, it's just do these, put it here, and do these. Because it's more efficient. So you're using GCD to do which has higher chance of getting one, getting one faster. We can try if we do another way. Like we do here, we do here, we turn this into 2, and then this will be some value. Then we turn this. This is like GCD of GCD. Alright. Once we're done, we eliminate this one. We don't consider this one anymore. Then we just do the GCD. So this is GCD already. Alright, this is the GCD, and then we do the GCD with something else. like it can be another GCD, or if, because this is already the minimum. Okay, so maybe we need to change this a little bit. Maybe we can say start. Well, start is smaller than nums.size. So I'll start. Actually, I'll say start plus 1. And size, and I say this equal to -1. And this, right, if equal to 1, this is fine. Otherwise, I say start plus plus. Let's see if it works. That is not right. Because basically we have this equal to 1. Yeah, you go, 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 go. Huh. Oh, because you have all those. Yeah, it's not. I think this approach probably didn't work. So you do that, and then you find out nobody's one, so you have other GCDs, right? Then what you want to know is whether any two number because the only way is for the GCD to move, right? Because you can replace either left or right with GCD, and the other one has to stay the same, which means the GCD can move forward or move backwards. So you get first round, get the GCD. So in this case, we have GCD, we get a 2, right, and then we get a 5. Right, we get a 2 and then we get a 5. But how do we know that we can do 2 and 15? How do we know that we can do 2 and 15? Like, we don't need, basically, this is saying we don't need another GCD, right? We don't need another GCD. So yeah, we do the first round, right? And does not have. Or maybe because it's always better to, I don't think it's always better. If you need to move the GCD around. Compared to you start from some, yeah, like if I have another value in front, and then this will be not efficient. You could just start from here. What else? What else information that we're not taking in? Either. So maybe we shall DP this thing, right? So basically, if we want to DP, we say minimum number of operations to make. So we want to find a minimum operation to find a 1. Right? Minimum operation to find a 1. So how do we do this? So we say minimum operations. Maybe what we can do is just iterate through all, because it's only 50, right? The length is only 50. So we say first operation, and this, and then this, and this, and then we can do, another operation like this, another operation like this. So yeah, so one operation will generate 2, right? Will generate 2, like this and this, and this, and then we can do, this operation will generate 2, and this operation will generate 2. So yeah, so first we'll turn this into a lot more, like each one get 2. And then the follow-up for each one. Or you can say we start from. But still not right, because you can start from 2 sides, right? You can start from here, and you can start from a different position, and then they meet in the middle, right? It all works in that sense, right? It all works. So yeah, how do we handle this? I don't know. Hints. Try finding the shortest subarray with a GCD equal to 1. Try to find the shortest subarray with a GCD equal to 1. Shortest subarray. Of course, it started with 2, right? And if nothing works, then we say we do 3. How do you find if it's... You just GCD them all together? Is that how? What is the subarray? Yeah, if it's only 2, then we just do that, right? What if it's 3? Well, if it's 3, you have 2 options. You can do this, right? Or you do this. But we know individual are not 1 because we tried it already. So we actually have individual values, right? But so it has to be an individual, a pair with somebody else, or so either a pair with that or a pair with that, or it's 2 pairs, right? Or it's 2 pairs. But I doubt it needs to be 2 pairs though, because if, let's say, the first pair generate something, let's say 2, and the second pair generates 3, right? So you have the one in the middle. So the one in the middle must be a multiplier of both 2 and 3. And the one on the left doesn't have 3. And the one on the right doesn't have 2, which means the one on the left and the one on the right, they are, I'm hesitant to say they're co-prime, but I think they are co-prime. Right? So like the one in the middle, so A0, A1 has 2, right? A0, A1 has 2. And A1, A2 has 3, right? So A1 is 2 times 3 times something, okay? And since A0 and A1 GCD is 2, which means A1 doesn't have 3 or the other thing, right? So A1 just 2 with something else. And oh, hold a second. Yeah, that's not necessarily true, because A0 can be 2 times a specific number, and A2 can be 3 times a specific number, and that specific number is not an A1. So we cannot say if the left and the right are co-prime. That's not true. But what we can say is if A0, A1, that value, and A3 and A2, if they... So we basically just put them all together. GCD the entire subarray. You know, we just GCD the entire subarray until we find one is 1, and then that shall be the case. So yeah, we just GCD the whole thing, right? If it doesn't work, we just sliding window to the next one, we GCD the whole thing, because that's how we find 3. That's how we find 3. So now we're gonna find 4, right? We're gonna find 4. So because we did 3 already, we know 3 doesn't work. 3 doesn't work, so we have to get 4, which means we need to get, GCD the first 2, and we know GCD with this doesn't work, but what we don't know is it's GCD with the last one, because we add a new one, right? We don't know if that one works. So we either do like 1, 2, 3, or we do 1, 2, 3. So I think with a hint, what I'm gonna do is so it's not pairwise G, so yeah. Pista. So what I know is to find the first occurrence of 1 via GCD, right? Then the answer is the number of steps to get 1 plus the length of nums minus 1. So what I don't know is how to find the number of steps to get the initial 1. The hint says to find to go through all subarrays, and for subarray to reach 1, we can simply GCD all pairwise elements. Yeah, all pairwise elements. That's the shortest way. So we can use a sliding window to find the minimum steps for all possible subarrays to reach 1. The first time a subarray reaches 1, that is the min steps to get 1. That is the seed we need to get 1. So we don't need this, we don't need this, we don't need any of this. So basically, ooh, what the hell? So basically, we're gonna go, and this is gonna be O(n) squared, I think, times O GCD. Alright, so sliding window, we want to start with 2, and every time we do, so we're and each one we have to do go, right? Go. So I'm thinking whether there is an easier way. So like if we do the GCD on this, but I need to remove 1 and add 1. Can I do, I don't know, prefix GCD? Is that possible? I'm not sure if it's possible because it's GCD. I don't know. And then if that's the case, I think it's O(n) tripled. So what we do, we have for int subarray sublength with already 2, right? Length smaller equal to nums dot size, right? Sublength plus plus. Okay, that's the sub length. And then we have for int I0 I smaller than nums dot size minus sub length, and then I plus plus, right? So this is actually, I think, maybe smaller equal to, because I can do in -2, right? Okay. Now within each one we have to do again int, we can say temp, and then we just temp equal to this, and then everybody just GCD against that. Okay, so temp equal to nums I for int j equal to I plus 1, j smaller than I plus sublength, right? And then j plus plus. Temp equal to, yeah, temp equal to GCD temp and nums j. Okay. If temp is equal to 1, then I return, as I take 1 step, 2 step, right? So we return sub length minus 1 plus nums dot size minus 1. Otherwise, return -1. All right, let's try this one. Hopefully this one is good. I forgot, my bad. All right, let's try this one. Okay, sublength should be 1. I'm not sure if sublength 1 will work. Yep, I think this shall work. No, I think this is a special case. This is a very special case. But you should get 1, because I can have a case like, I don't know, like 1, 1, 2. Oh, 1, 1, 2 is also not going to be right. Darn. Darn. Okay, we need to pre-process this thing. Oh my god. Okay, we need to pre-process. Get rid of all the 1s. Get rid of all the 1s. No, it's just we need to go through if it is a 1 and the number of, yeah, so int none 1 count. Okay, so int n of nums, can say none 1 count plus equal to n is not equal to 1, right? If no 1 count is smaller than nums dot size, then we already have, let me just return none 1 count, right? So we already, there is already 1 in nums. Right, otherwise there's no 1, then we will do whatever we need to do. All right, so this hopefully is sufficient. Come on. All right, There we go. Took a while though. It definitely took a while. It took a while, and that's from hint. I was even thinking about DP stuff, but yeah. Same. I think it was the same the last time. Took me 2 shots. Did I do it by myself or did I? I think I did it by myself. Not like this time. This time I actually did not do it by myself. What did I do? While Q. GCD. Then what? Step plus equal 1, then for each one I try QI and QI plus 1. So initially it is all the GCDs, right? GCD, every GCD. And then I basically do GCD of GCDs. Okay? But the steps is count as this is a 1 round. And that's the 2nd round. So I didn't multiply by 2. Huh. So we count that as 1. Okay. And then the next one we count as the 2. Because we're basically just doing them GC together. Yes, it's the same. It's the same concept. It's the same concept. But this one is much simpler. However, it's a hint. Last time we did it by ourselves. Yeah. All right. Anyway, that would be it.